Another cool thing about Optimus is that just in the US alone, there are 2 million amputees. I was just talking to the Neuralink team, and by combining a Neuralink implant and a robotic arm or leg for someone that has had their arm or leg, or all arms and legs amputated, we believe we can give you basically a cyborg body that is incredibly capable.
Elon Musk announces a future where technology surpasses the limits of physics. A groundbreaking solution that combines Neuralink implants with advanced robotic limbs, where a prosthetic arm or leg is not just a replacement part, but a powerful cyber body controlled directly by thought. This not only restores mobility, but also independence and confidence. Get ready to witness a quantum leap in human capabilities as sci-fi becomes reality in today's episode of Tesla Car World. How are Optimus parts implanted into the human body? Elon is exploring how to regrow lost limbs and organs. They're using AI to better understand how our DNA works, which helps them figure out the exact spot where the limb originally grew without damaging any surrounding tissue. Once they got that, they can regenerate the limb in a lab. Yes, it's like growing it in a petri dish, then reattaching it to the body. The brain, being the amazing thing it is, starts remapping the nerve fibers to work with this new limb, and to make things even faster, a little electrical stimulation helps speed up the brain's learning process. It's like giving your brain a nudge to figure things out quicker. Next up, what you can do when we have all these fancy new Optimus limbs in our future, you'll be able to get some low-hanging fruit initially. It can raise, lower, or rotate your arm or leg. Some examples include saying hello by a wave, or pointing to different objects, or taking a break to grab a cup of coffee. With these fundamental movements, you can perform your daily routine of picking up things off the floor or getting ready for work that includes opening doors and never again asking for someone to help you open up that pickle jar. But wait, it gets better, and with more practice, you'll be able to handle complex scenarios, write and type again, cook your favorite meal, even play an instrument from scratch. It can all be done with ease using both new limbs. So, with the right engineering, you can work some robotics into your limbs and still have a measure of that control, so using them will feel natural enough to perform more complex tasks without feeling buried in metal. Optimus's flexible hand structures is a testament to this advanced technology. The robotic hand is designed with 22 degrees of freedom, allowing it to mimic human hand movements with unprecedented realism. This is achieved through a cable-driven system that uses just 6 actuators to control the whole hand, reducing complexity while maintaining fluid motion. The fingers can flex and extend almost as naturally as real human ones, thanks to innovative cable routing and torsion springs that stabilize the joints. This level of integration not only improves functionality, but also boosts the user's confidence and independence in daily activities. Of course, we all do drinking, eating, and getting dressed, and you'll be able to do it all. The visual controls built into the system will make sure that you can use utensils, open doors, and manage your clothing easily. No more fumbling with buttons or struggling with zippers. And here's where it gets even cooler. Over time, the system actually learns how you move and what your preferences are. It's adapting to make things more comfortable and tailored to how you like to do things. It's like your new limb knows you better than your own hand ever did. And for those needing a little extra help getting back into the swing of things, the technology can be used in rehab facilities. You'll get guided exercises and feedback to help regain motor skills and promote recovery. It's like having a personal trainer for your new arm or leg. And in the future, these systems might even come with sensory feedback. Imagine being able to actually feel stuff, like touch or apply pressure, even temperature, through your robotic limb. That's a whole new level of integration, bringing back even more of that natural sense of independence. And the more you use it, the smarter it gets. The Optimus fingertips are equipped with sensors that detect pressure and touch, enabling the user to feel the objects they're handling. This tactile feedback can enhance the user's experience, making interactions with a robotic limb feel more natural. For example, picking up a delicate object like an egg without crushing it becomes possible with precise control and feedback. So, what's the exact principle behind how a simple chip like Neuralink can control prosthetic limbs like Optimus? Neuralink allows you to control a robotic arm using just your thoughts through a small implant with electrodes placed in the brain's motor regions, which detect electrical signals when you think about moving. These signals are picked up by the Neuralink device and processed into a chip that acts as a translator, converting your brain's activity into commands that the robot limb understands. The signals are then sent wirelessly to the robot limb, which is equipped with actuators and sensors that mimic human muscle movements. This allows the robotic arm or leg to move in sync with your thoughts, whether you're lifting a cup, waving, or giving a thumbs up. Let's take a look at the cases of Nolan Arbaugh and Alex. These are two real-life examples, which will help us understand how Neuralink can be used to control Optimus limbs. Nolan Arbaugh got his implant on January 29th this year, and a month later he was already demonstrating his ability to control a computer cursor with, get this, his thoughts. This case shows just how quickly Neuralink can start reading brain signals and translating them into precise commands to control external devices. The implanted electrodes in Nolan's brain were able to capture neural activity related to movement and intention. His brain sends signals as if they were using a mouse or joystick, and then Neuralink interpreted those signals and transmitted them to the computer, allowing him to control the cursor and interact with online games. If Neuralink can process brain signals to control something as delicate as a computer cursor, it can certainly handle more complex tasks, like controlling a robotic arm. A cursor requires fine motor control and precision, a lot like the small movements that a robotic limb would need to perform everyday tasks like holding a cup or typing things out. Now, for the case with Alex, the results, they were even faster. Within just 5 minutes of getting his Neuralink implant, Alex showed improvement using CAD software and doing some video games, demonstrating how effectively and quickly Neuralink can interpret neural signals and apply them to complex real-time activities that require detailed motor control. CAD software in particular is highly demanding because it requires precise hand movements to manipulate objects and make 3D designs. Similarly, gaming often requires quick reflexes and coordination between the different controls. When Neuralink can improve performance in a complex task like CAD design within minutes, controlling a robotic limb like Optimus could become second nature. The system converts brain signals into specific movements, just as Alex's brain guided the CAD software or video games. This technology can be applied to robotic limbs, allowing users to control them quickly and efficiently as if they were their natural limbs. Both cases demonstrate that Neuralink provides precise real-time control over digital activities. The same principle applies to robotic limbs. Movements would be quick, accurate, and responsive thanks to the way Neuralink translates neural data into mechanical actions. So, how much does an implant cost?
$6 million man in real life. But what won't cost $6 million? $60,000 man. Doesn't sound impressive, but it'll actually...
Musk estimates the cost to be around $60,000, but the final price for implementing an Optimus arm or leg for patients has not been specifically disclosed yet. In reality, these costs may include not only the price of the device itself, but also expenses for surgery, post-op care, and necessary rehab. We know that the cost of implanting a Neuralink chip is estimated to be around $10,500 for the exams, parts, and labor, but when factoring in insurance and other costs, that price could rise to about 50 Gs. Overall, the estimated total for the project is to be no more than $100K. In exchange for what many people call a wallet-busting price, it's important to remember that this is a proven technology with high feasibility. The results have been clearly demonstrated not just through extensive testing, but also through approval by reputable authorities and having been tested directly on people. The path to Neuralink's regulatory approval involves continuous monitoring and adherence to safety guidelines set by orgs like the FDA. This collab includes regular updates and evaluations to ensure the tech is safe for human use. The iterative testing and modifications of the implant based on participant feedback and outcomes demonstrate a proactive approach to enhancing safety and reliability. In the first human implantation, Neuralink's N1 implant successfully recorded neural signals immediately after the surgery. The implant utilizes 1,024 electrodes distributed across 64 flexible threads to detect neural activity. Approximately 85% of the electrodes implanted in the first participant were successfully retrieved, indicating a high level of reliability in the device's design. The implantation surgeries were performed by the Barrow Neurological Institute, and participants were discharged the following day with a smooth recovery process. According to our updated information, the implantation process has undergone different changes and improvements based on lessons learned from the first surgery, which have been applied to the second. The Neuralink chip implanted in Alex, the second patient, demonstrates a notable advancement over the version used in Nolan Arbaugh, the first patient. For Nolan, the N1 chip had 64 threads, each containing 16 electrodes, totaling 1,024 electrodes implanted in the brain. For Alex's case, the research team made some adjustments. The number of threads was doubled to 128, and the number of electrodes per thread got reduced to 8. Despite the decrease in electrodes per thread, the new chip still has the total 1,024 electrodes. And upping the number of threads allows the chip to access more areas of the brain and gives greater stability in recording neural signals. Doubling the number of threads to 128 effectively doubles the bandwidth and improves signal accuracy. This means that the chip implanted into Alex can capture neural signals with higher detail and stability than Nolan's, opening up greater potential for control with the brain. Less than 3 weeks after surgery, Neuralink reported that 400 of the 1,024 electrodes in Alex's brain had begun functioning, showing positive signals earlier than expected. After getting the Neuralink chip, Alex was able to both aim and move in the game at the same time, describing this experience as mind-blowing and being thrilled to be able to move and look in all directions just by thinking. These results highlight the tremendous potential of this technology to improve the quality of life for individuals with disabilities, such as survivors of car accidents or veterans. From an economic perspective, the potential of this technology is quite significant. If Neuralink can develop brain-controlled prosthetics, the market for these products could grow into a multi-billion-dollar industry. The demand for assistive devices for people with disabilities and those in need of rehab is increasing, and advanced technologies like this can meet these needs more effectively. Furthermore, with the growing awareness of mental health and issues related to trauma, technological solutions like Neuralink could become an essential part of treatment for many patients. What are Neuralink's future implant plans? If all goes well, there will be hundreds of people with Neuralink within a few years, maybe tens of thousands within 5 years, millions within 10 years, Elon claimed. Neuralink isn't just stopping at the telepathy chip. It's gearing up to roll out its next game changer, the blindside chip, which has already earned the coveted breakthrough device designation from the FDA. Blindside is approved for a voluntary program, and their next patient, a blind individual who's going to get this visionary tech. Elon's made big plans. He's aiming for 8 surgeries by the end of this year, bringing Neuralink's count to 10. But here's the kicker. By 2026, they could have over 1,000 people walking around with these brain chips. So, what's the blindside chip all about? Well, it uses electrodes to stimulate nerve cells in the retina, mimicking light cells to help the brain see actual images. Initially, the resolution might be a bit pixelated, but here's where it gets crazy. Elon believes it could eventually surpass our own human vision. Plus, Neuralink plans to integrate external cameras to beam enhanced images straight to the brain, making this tech even more futuristic. And of course, being Elon Musk, there's the next stage, and he envisions a future where we could see ultraviolet, infrared, or some kind of radar-like vision through Neuralink. Yeah, straight out of sci-fi movies. While this opens up possibilities for communicating with AIs in ways we never even dreamed of, next-gen superpowers, anyone? Combining Neuralink's brain-computer interface, or BCI for short, technology with Optimus's robotic limbs, the two put on a display that could change life as we know it for amputees and anyone who suffers from paralysis. It allows a person to direct motorized prosthetics using just their thoughts rather than relying on injured nerves and muscles, leading people with amputations closer to everyday tasks like getting dressed or cooking. This could also be used for survivors of accidents and our veterans, giving people back otherwise lost limb function or slowing the decline in motor skills that occur in diseases like ALS. In dangerous fields, it could also aid workers by tasking robotic limbs to perform hazardous activities alongside them and work as a tool for recovering from an injury. This integration of BCI with robotics presents new opportunities for physical augmentation and significantly improves the quality of life. How does Neuralink change the patient's worldview? The first Neuralink patient, Nolan Arbaugh, underwent an implant procedure 7 months ago. He can now learn additional languages like Japanese and French, and in the near future, he aspires to go back to college to either finish his degree or pursue new research in the field of neuroscience. 8 years ago, a diving accident robbed Nolan Arbaugh of his brain and body functions, but he's regaining them with the help of a chip implanted in his skull 7 months ago. Until now, Nolan's recovery was filled with many interesting and surprising twists and turns with how well the chip worked, and from then on, day in and day out, Nolan has worked alongside Neuralink to calibrate Eve, not just for him, but it also so that it benefits future patients. He recently shared what he does on a daily basis with Eve and the Neuralink team in his tweet. Through it, he describes in great detail his progress and recovery process with the help of Neuralink. He flexes his fingers, focusing on clicking left, right, and center with different parts of the body to type while attending a creative writing workshop. He pictures himself holding a pen and writes characters that are converted into key presses, demonstrating the resilience of his brain chip. He tackles a pretty impressive workload every day, dedicating around 3 hours each day to learning French and Japanese, and Nolan has also chosen to relearn math from the ground up, hopefully returning to school. Each day, he spends about an hour reading, and he has recently started writing creatively again, reflecting his determination and zest for knowledge. Nolan's aspirations extend beyond just academics. He aims to earn a college degree or explore new frontiers in neuroscience. His ambitions also include publishing his creative works, starting a charity, and even building a home for his parents. It's evident that Neuralink's chip has profoundly transformed Nolan's life, enabling him to vision a future filled with possibilities. Alex, the participant directly after Nolan, was also able to break a previously held world record on day one of using it and controlling any cursor through brain-computer interface with a Neuralink device. Alex kept playing after the completion of first research session via Counter-Strike, a first-person shooter game. By the second day of allowed use, Alex was using Fusion 360 for the first time and designed a custom mount and charging station for his Neuralink that he then printed into Final with part of his Link setup. Thanks to the Link, Alex can enhance his productivity by mapping intended movements in different actions with specific mouse buttons, increasing further the number of controls and being able to instantaneously change between several modes like zoom, scroll or pan, click and drag, or similar operating behavior needed for CAD software videos. When he has extra time, Alex employs CAD software to further fabricate ideas of his design skills. Eventually, he wants the Link to empower thousands of people all over the world and help them create in their fields, and once again is amazing its many members. But until then, they were thrilled at getting started on more work with him. In addition, Alex plays first-person shooter games, which often uses multiple inputs in the form of 2 joysticks. With the Link, Alex can now move and aim at the same time with his shooter games for a new level of differing gameplay. For him, the Link's a big step on the path toward regaining freedom and independence, Alex said. Do you think technologies like Neuralink's brain chips will eventually become common enhancements for everyone, or should they primarily remain for medical use? We hope you'll experience the utmost relaxation after watching this video. If you did, hit that like button and join the Tesla Car World community by subscribing to our channel and hit the notification bell icon to stay tuned for any fantastic vids coming your way. Your feedback and time are highly appreciated. Thank you so much for watching, and we look forward to seeing you soon. Until then, take care and God bless.